Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we continue working with hyperbolas here, and we're just going to use the standard theorem we introduced a moment ago in the previous video to help us graph a hyperbola. Now recall, the standard form for a hyperbola, there's two of them. One would be x minus h being squared over v sub x squared minus y minus k being squared over v sub y squared is equal to 1. And the other one is the same, but with the x's and y terms swapped. That's all. So we know that the center would be at h comma k, and the vertex would be, well, actually, I should say vertex would be v sub x units from h comma k along major axis. Well, I should say in this case, it's the horizontal axis because our only positive term here is the x term. And so that would mean our major axis is horizontal. And finally, the foci, they're c units from center. And again, along the horizontal axis. And I just want to remind you that in a textbook, they would call that the transverse axis, is the major axis, or the one that's associated with the positive variable here. So let's go over to this. Notice this is not equal to 1. It's 9x squared minus 4y squared is equal to 36. So we'd like this to be equal to 1. That's the first trick when working with any type of conic, really, other than parabolas. You want that right-hand side, or the side with the constants, to just be 1. So dividing both sides by 36, you get x squared over 4 minus y squared over 9 is equal to 1. Notice x is the positive variable, so I happen to know that the transverse axis, oops, that's not how you spell transverse. The transverse axis is horizontal. And that's all you really need there, because just to notice that the variable associated with the positive term is the x value. V sub x is going to be 2. That's the distance from the center to the x vertex. That's 2. There's no such thing as a vertex. Well, they call it a minor vertex or a co-vertex, but we don't really have to worry about saying there's a vertex in the y direction, because the transverse axis, or the major axis, is horizontal. There's no need to mention that. It is kind of nice to mention what v sub y is, however, because we're going to be using that. And we might as well say how far away from the center that the foci appear. Well, remember, c squared is always, for hyperbolas, going to be v sub x squared plus v sub y squared. Or in other words, c will be the square root of v sub x squared plus v sub y squared, which is equal to 4 plus 9, 13, square root 13. So not a pretty number, but we'll just deal with that. And anything else? Nope. Oh, center. I should say center. The center here, kind of easy to see. We don't have like x minus h and y minus k. We do, but h is 0 and k is 0. So the center is at 0, 0 in this case. Let's go ahead and start graphing. Now, the first thing that I do when I'm graphing any type of hyperbola, whatever, I kind of just deal with the major axis stuff. So the center, I'll draw that in blue. Obviously, that's at 0, 0, so no biggie. And the vertices, right? So remember, it's a horizontal transverse or major axis. So we're going to go ahead and count v sub x units from the center on both sides to arrive at our vertices. So 2 units to the left and 2 units to the right. Let's actually be somewhat accurate about this and involve my ruler. So 2 units to the left and to the right. Let me zoom in here and let's use, how do I want it? 1, 2, maybe I'll call this 2 units. 1, 2, and that's 2 units. So these are my vertices and I can't leave that ruler on there because it'll draw my pen. Let me scoot it down a little bit further. So there's one vertex at 2, 0, and the other vertex again right here at -2, 0. These are not the foci, they're the vertices which occur on our curve. Then I'm going to plot my foci, which occur c units from the center, root 13 units from the center, and that's a number between 3 and 4 units from the center, because root 9 is 3, root 16 is 4. So I'm going to say it's about 3.5 units. I'm not going to grab a calculator. I'm just going to kind of eyeball it, 3.5 units. And I'll do the foci in red here. So if that's 2, 3.5, we'll just say, and if that's 2, 3.5. All right. So again, moving that down, here's our foci. This is going to be at root 13, 0, and the other foci will be at negative root 13, 0. Notice that I just took care of everything on the major axis first. Now I'm going to worry about how do I graph everything out? I need guidelines. And the guidelines to graphing for a hyperbola are going to be the asymptotes. And that is going to be something you have to get used to in calculus, working with asymptotes. So the equations of the asymptotes are like this. Y minus k is equal to plus or minus some slope times x minus h, where h and k are the x and y values correspondingly for the center. Now we happen to know here that our center is at 0, 0. So our asymptotes are at y is equal to some slope plus or minus times x minus 0. What is that slope? It's rise over run. It is the y value rise over the x value run, 3/2. So that's how I've always done it when I was a student. It's actually literally just v sub y always over v sub x always. And now I can go ahead, go here, and I could say, oh, my asymptotes are y equals plus or minus v sub y is 3, v sub x is 2, so plus or minus 3/2x. Those are the asymptotes. I will just write it that way. Now, let's scratch those out. And again, I probably need, because it's a rise of 3 over a run of 2. So let me go ahead and mark the rise of 3. Now, everybody has a different way of doing it, how they do this, and that's totally fine. I don't judge you if you have a different way of doing it. I'm just doing it my way. So this is 3 up here, and I want to go 3 down. 1, 2, 3 down. Okay. And let's see, 3 up and over 2. I'll just mark that out very quickly. 3 up and over 1, 2. And that's okay. I'll just do it this way. 3 up and, well, yeah, that's fine. 3 up and backwards 2. That's all I really need. So here we go. Now I'm just going to connect, because it's a diagonal line, or I should say a line, going through the origin here, because that's the center, and the point 2, 3, because the rise is 3, the run is 2. Let me try to get that as accurate as possible. So this right here is one of my asymptotes for graphing. Asymptotes are incredibly useful for graphing, so let's scratch this out a few more times here. All right. And in the other direction, again, I rise 3, but I'm going to go back 2 just to get the other asymptote. Again, rise over run. That's good enough for me. And I'll just scratch these out like that. I don't need them to be like super nice or anything. Okay. So those are our asymptotes. And now when you go to graph the curve in blue, your curve is going to want to eventually tend to those asymptotes. So this is kind of a process here to learn how to graph these appropriately, but they'll approach those asymptotes. You can see they kind of do there. Same thing on the other side. It's going to approach the asymptote on the other side. It won't touch the asymptote, but it'll get super close to the asymptote. There we go on that side, and again on the other side. There we go. That is the graph of that hyperbola. Really very nice. Now, this is an okay hyperbola. It's centered at the origin. It's not a terribly challenging hyperbola. Let's see what happens if we're given one that's not centered at the origin and is also not in a pretty form like this, but actually in what we call general form, which technically this is in general form, but when you have something not centered at 0 and it's in general form, it's a bit of a mess. So same instructions here, but notice this is a bit of a mess, right? We have all this stuff all over the place. There's a lot of completing the square that you need to do to figure out all the values in this hyperbola. So let's start by getting rid of fractions. That's kind of my first advice to anybody. Just multiply everything by the LCDs within the entire equation, which is 4. Now, if you do that, I hope you know 473 times 4 is going to be massive. There's no way around it. That's just how life goes. I'm going to quickly do that with a calculator. And we get down to that. So kind of simplified it. Now you're going to move all the terms with x's and y's to one side, just like the proof of the equation for a hyperbola. You're going to move all variable terms to one side and keep all constant terms by themselves on the right hand side. So that I can actually just write down right now without pausing the video. So that's 49y squared plus 196y. And then you have this minus 36x squared plus, minus 216x, and that is equal to 1892. This looks very daunting, kind of scary. What we're going to do is complete the square. So I'm going to color code things here so that it looks somewhat nice. I will factor a 49 off of both the y terms. And when I do that, I'm left with a y squared. What is that? Plus maybe 4? Let's see, 4. Yeah, I think that is 4. Plus 4y, and I'll leave a little space there. And I'll factor a 36 off of, or a negative 36 technically, off of the x squared terms. So if I factor a negative 36 off that, I'll get x squared, and let's see, I think that's going to be a positive 6x. Let me just double check. 180, yep. And then that's going to equal 1892. Now what do we do? Well, you should be very familiar with completing a square. In blue there, I'll take half of that 4, which is 2, right? And I'm going to square it. So it's a positive 2, and then I'm going to square it. So add that positive 2 being squared. That's how you complete the square. In green, I'm going to take half of that 6, which is a positive 3, and I'll put it right here, and I'm going to square it. So plus a positive 3 being squared. Now, obviously, we didn't start with that positive 2 squared, nor did we start with that positive 3 squared. So we're adding some stuff to the left-hand side that we need to also add to the right-hand side. Specifically, we're adding 49 times 4 to the left-hand side, so we better add 49 times 4 to the right-hand side. Also, we're subtracting 36 times 9 from the left-hand side, so we better subtract, and that's green, right? We better subtract 36 times 9 from the right-hand side. Okay, so let's go ahead and do that, and then you can see in the blue ink there, we have 49 times that trinomial factors to y plus 2 quantity squared. And in green, we have minus 36, and that trinomial factors to x plus 3 quantity squared. And on the right-hand side, well, there's just a lot of constants, so you might want to grab a calculator. That's going to be 1,764. Now what I'm going to do is, because I want to get this into a hyperbola form or hyperbolic form, I need to divide both sides by 1,764. When you do that, dividing both sides by 1,764, 1764 goes into 49 36 times. So this is going to be y plus 2 quantity squared over 36 minus, and 1764 divided by 36 is 49 actually. So this is going to be x plus 3 quantity squared over 49. And now I'm ready to talk about all the important pieces. One thing you should note, this is definitely a hyperbola because it's a squared term on your variable minus the squared term of the other variable, so that's a hyperbola. The major axis here will be vertical because the y is the positive value. See, v sub x is 7. V sub y, the denominator, the denominator of the y term, the square root of it, is 6. Notice that unlike an ellipse, the larger denominator does not tell you what the major axis is. With an ellipse, the larger of the two denominators would tell you the major axis. But with a hyperbola, it's the denominator associated with the positive variable. All right, let's see what else we need. C. Well, we know c squared is v sub x squared plus v sub y squared. So that would be, well, that'd be a mess there, right? 36 plus 49 is 70, 85. So this is going to be the square root of 85 is what c is. C is root 85. I'm sure that we can figure out 5, 35, 17. That doesn't really, there's no pretty way to reduce that. So let's see, we got all that going on there. Now I'm ready to go. I'm ready to do this. Oh, one other thing actually. My asymptotes, the center, actually, two things. The center is going to be at -3, -2. So let's write that in here. The asymptotes, y minus the y value for the center, is equal to plus or minus v sub y over v sub x, so 6/7, x minus the x value for the center. And that would be, really, it doesn't matter. I'll just leave it like this. Y plus 2 is equal to plus or minus 6/7, x plus 3. Okay. Now we're ready to actually graph. Let me prep the graph. And as I mentioned in the previous problem, I like to work on the major axis first. So let's plot the center, which is at -3, -2. And notice the sizes of v sub x and v sub y. We're going to need to kind of squish this down a little bit because we'll want our vertices 6 units up and down from the center. So I'm going to be somewhat careful about the size of my axes here. I'll say that each of these half pips is 1. So let's go ahead and do that. So there's my -3, -2 for my center. Then what I'll do, again, working on the major axis, which is the vertical axis, I will plot the vertex 6 units above and below that point. So again, I'll use blue this time for the vertex and 6 units above and below that. So let's go ahead and get this at 90 degrees, 6 units above. So let's see, 2, 4, 6 units above, and 2, 4, 6 units below. So this point right here will be a -3, -8, and that point up there will be at -3. Darn it. Let me zoom in. -3, and then we're adding 6 to -2, which is +4. The focus, or the foci, I should say, are root 85 units up and down from the center. Square root of 85, let's see, root 81 is 9. So it's going to be slightly greater than 9 units above and below. So I'll just count out 9, honestly. So let's go ahead and just do that. Let's see. All right, that's 6, 8. So this is probably right about here, 9. And let's see, another one right about here. So that is roughly root 81 or 85, sorry, units below. So I'm going to label this as -3 comma -2 minus root 85. And the one above is at -3 comma -2 plus root 85 units. So climb up root 85 units and drop down root 85 units from the center. Now that's everything along the major axis. Now I just have to graph the rise over run. Rise over run is 6/7 or -6/7. And that'll give me my asymptotes. So you always start at the center. You go up 6 units, which actually is where that blue curve, you go up actually, rise over run, 6/7. So rise 6 units, that's good. So that's actually where the rise of 6 is, and run 7 units from there. And actually, I would just do 7 units in both directions. So let's see, 4, and I'll use green for this. 3, 4, 5, 6, 7 units this way. 1, 2, 3, 4, 5, 6, 7 units this way, roughly. Now you just connect those points to the center with a nice dashed line. And I'll be kind of, well, I suppose you don't need a dashed line. Let's just do a solid line there. It's okay. Some people like the dashed line, some people don't care. I don't care. So doing this right like that. Now I don't need my ruler anymore. I'll take that off the screen. And now I'm just ready to finalize my graph by going ahead and graphing a smooth hyperbolic curve. And this might be a little bit tough to freehand, but I'll try my best. Oops, screen moved there. That's weird that my screen makes my hand do that. All right, so that's one direction, and then the other one, just like this. There we go. Not bad. That is our beautiful graph of our hyperbola. Not bad.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry. Don't whine. Just